I'll just give you an example of an outline of what I'm going to be doing this morning rather. It feels like night to me, but it's morning. First of all, I think it's always important to realise that it's a battle between two worldviews, two philosophies, which is what people interpret the evidence according to their philosophical belief system. That's important to get around first. And then, since we're talking about the origin of life, we have to work out what do we actually need before life will occur. So I have to show you how complex even a so-called simple cell is. There's no such thing as a simple cell, as I'll prove to you. And then get into my own field of chemistry and show that there are chemical problems with chemical evolution. Now, chemical evolution is the usual name given to the theories of life from non-living chemicals. Now, you might find in internet debating sites that they're trying to say the origin of life is not part of evolution, but traditionally it has always been part of the theory of evolution. It's what the materialists need to explain. They need to have an explanation. If they don't want to believe in God, they have to have some way of getting from chemicals to living cells. And so it is part of a theory, the general theory of evolution, or as I like to call it, from goo to you via the zoo. And there's a few resources just on the origin of life. And one of the book we have is called The Mystery of Life's Origin. It is a little bit technical, but it's very well worth the read. And on our website we have a number of articles on the origin of life in this, one of the question and answer pages on quite a few different issues, quite a number, about 20 or so articles on the origin of life and problems for the atheistic evolutionists. And also I'd like to remind people that we are supposed to be able to be ready to give an answer to everyone who asks you to give the reason for the hope that's in you. And that's not just a command for pastors or for creation speakers. Everyone should be ready to give a reason for the hope that we have. And also, according to the Bible, what Paul said is that the evidence for God is so obvious. He said the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so they are without excuse. You see, no atheist on Judgment Day is going to be able to tell God, I didn't have enough evidence to believe in you. Because the evidence should be so plain from what's been made. And Paul goes on to say that they knew God but did not glorify him as God, nor were thankful, but became futile in their thoughts, and their foolish hearts were darkened. That's pretty strong language. But it really gets the message across that atheists are futile in their thinking, and I think chemical evolutionary theories are the epitome of futileness. But here's an example of the bias that you get from the people researching evolution. See, a Kansas University professor, he said, even if all the data point to an intelligent designer, such a hypothesis is excluded from science because it's not naturalistic. He's saying no matter what evidence he has, he's not going to believe in a designer because he's already excluded it without even looking at the evidence. He's already made up his mind there's no such thing as a designer because it's not scientific. And that's the exact opposite from what Paul says. And another scientist who is somewhat skeptical of the origin of life ideas, an information theorist called Hubert Yockey, he's not a creationist, but he said research on the origin of life is unique in that the conclusion's already been authoritatively accepted. And all we have to do is find out the scenarios and the mechanisms by which it happens. See, they've already made up their mind that life came from non-living chemicals. Before even looking at the evidence, all they're trying to do is trying to find the chemical evidence to back up their belief system. But their conclusion's already there, that life somehow or other came from non-living chemicals. And Yockey himself said that contrary to the established and current wisdom, a scenario describing the genesis of life on Earth by chance and natural causes that can be accepted on the basis of fact and not faith has yet to be written. Now, he wrote that 25 years ago, but he hasn't changed his opinion since. He is still of the opinion that there's no good theory of the origin of life from non-living chemicals. Therefore, this idea is accepted by a blind faith and not by real evidence. Now, it's interesting because the evolutionists want to say that we're the ones who have blind faith and they're the ones who go by evidence, but in fact, the opposite is true. Because it's very important to understand, whenever you read an origin of life paper, they've already assumed that chemical evolution has happened. Well, it must have happened because we're here, aren't we? So you get the idea there. We're here, therefore evolution must have happened to get us here. But how do we actually understand if something's been designed? I'd say that the living things shout that they've been designed. It's so obvious. But the thing is, we're made in the image of God, and part of our image of God is our creativity, and we make things. Now, how do we tell if something's been made? Well, for one thing, we look at this jet fighter here, and one thing about the jet fighter, it has oodles of correct components. The point is, a wing won't fly by itself, and neither will a tailplane fly by itself, and the cockpit won't fly by itself, and the jet engine won't fly by itself. And in fact, you look in our Creation magazine, the current issue, it talks about how the Wright brothers designed the first airplane, but they actually made a lot of studies on the way natural flies work, the birds, designed by God. And the Wright brothers were very committed Christians. They looked at the way God had designed birds and used that to design the first airplanes. The point about this is that the components have to be organised correctly. So not only do you have to have the correct components, but they must be organised correctly. And as we can do a proper scientific experiment, science is about things which are repeatable and observable in the present. Like if I tell you that water boils at 100 degrees, you don't have to take me on faith, do you? You just go and test it yourself. But the idea that, say, a reptile turned into a bird 150 million years ago, well, I don't know how you're going to test that. Go back in time in the TARDIS or Star Trek Enterprise? Not likely. And of course, nowadays there's a dinosaur turning into a bird, so instead of KFC, it's KFD, I guess. But here's another experiment you can do. I mean, those of you who have children, do you have to tell your children to mess their rooms up? Well, I ask this because the evolutionists try and say that all you need to make order is a flow of energy. Well, the children are bundles of energy. If you let them go to it, they're going to make more mess, though, aren't they? If you want them to tidy the room up, you have to tell them to do it. They have to use organisation. See, organisation requires an organiser. To give you an example of what we're up about, let's put this frog in a blender. See, the blender's pure energy, isn't it? And what happens, you flick the switch and it goes, and you get frog soup. So why did the frog die here? Because it was disorganised. And you realise, you think, if I left this for millions of years and zapped with any sort of energy like ultraviolet, heat, gamma rays, X-rays, shook it up, do you think a frog's going to hop out of there again? Well, okay, why not? All the chemicals are there, all the components of the frog are still there. The point is, they've been disorganised and they're not going to organise themselves. And in fact, in this frog soup, you've got far more chemicals than any primordial soup could ever have. Because you've got lots of the proteins, the DNA is there. So the primordial soup that I'll show you will never get proteins or DNA. So this is far richer than any primordial soup, and yet no living thing is going to grow out of there. And in fact, also, whenever you can food, you are showing that the chemical evolution idea is just not possible, because the point of canning food is you sterilise it and seal it, and the point is no germ is going to generate in there. And in fact, if it becomes contaminated, you know very well the seal's got broken somehow, because you know very well that no bacterium, no germ is going to generate in a can of sardines, even though, again, a can of sardines is far richer than any primordial soup could ever be. And yet no germ will ever grow in there. And you've got billions of cans of food around the world, and so every time you open those and find it's not contaminated, you're disproving the evolutionary idea of origin of life from non-living chemicals. Now, what do you actually need to get a simple cell? It's pretty important to see what even a so-called simple cell must have. It must be able to reproduce itself, and by reproduction it means making a copy of itself. Now, think about trying to make a machine that could make a copy of itself. See, we can't even do that. So we can make a factory to make machines, but you can't make a factory to make another factory that will make the same things. So a self-replicating machine is incredibly complicated. And it must be able to transmit oodles of information down to the next generation. Now, this is important for natural selection. See, natural selection, I think Dr. Batten will be covering natural selection in one of his talks. And the point about natural selection is that certain information that codes for a characteristic which is useful for a living, like maybe stronger muscles or better or faster running, and that gets passed on to the next generation. So you have to have reproduction before natural selection can work. But therefore, if you haven't got a living cell in the first place, you can't use natural selection to explain it. You need the living cell before natural selection can work. So to produce the first cell, you haven't got natural selection, you've only got time and chance. And there's also the requirement of metabolism, because all the cell processes use energy. You've got to get energy from somewhere. So you've got metabolism and reproduction. Both of those are required for living cells. Now, we've actually got examples of very so-called simple cells. There's a parasite called mycoplasma. It can cause horrible things like pneumonia, for instance. They're nasty things, but they're the tiniest real self-reproducing life known. You see, a virus isn't really self-reproducing. A virus needs to hijack the machinery of more complicated cells to reproduce. It doesn't reproduce by itself. So a mycoplasma is the simplest thing that can make copies of itself. And yet it has 482 genes. Or, as we'll go on to show, 580,000 DNA letters, as it were. That's an awful lot of information, even for a so-called simple cell, and yet it's not really complicated enough. It can't survive by itself. It has to be a parasite to more complex machinery, more complex living things. Because there's certain things it can't get by itself. And in fact, on our website, we've got an article showing that possibly the mycoplasma and other parasites have become a result of loss of information to do the things it used to be able to do by itself. Now it needs other living things to do it for it, which is why it has to become a parasite. So before the fall, probably this thing was not a parasite. But after the fall, it deteriorated to such an extent that it needed to become a parasite. Now, some researchers, one of them is called Craig Venter, they're trying to design life from scratch. Well, not really from scratch, really trying to design it based on already known living things and seeing how many genes they could take out for the thing to still survive. And they estimate that they could possibly get down to 256 genes. Well, that's a pretty large amount. And they are very doubtful this thing would actually be able to survive because it's so depleted in information, it probably couldn't make a lot of the important things it needs. Now let's look at the cell and try and magnify what we need a bit. So here's an example of the cell, a lot of different components of the cell. Now when you try and break it down, which I'll try and do now, the cell is made of very big molecules. So you go down one level, magnify it a bit, and you find cells made of very big molecules called DNA and other big molecules called proteins. Now let's magnify this a bit more, and the big molecules are made of units of little molecules. So the DNA and protein are made of littler molecules. Combined, billions of little molecules are combined to make DNA. So there's a big problem trying to get from little molecules into big molecules, and then from the big molecules to organize into a cell. And here's what Michael Denton says about the cell. He's not even a creationist, but he wrote in the book called Evolution, a Theory in Crisis. I believe AIG still stocks this book, and he says to grasp the reality of life as it's been revealed by molecular biology, we must magnify a cell 1,000 million times until it's 20 kilometers in diameter and resembles a giant airship. And what we'll see then is an object of unparalleled complexity and adaptive design. A world of supreme technology and bewildering complexity. Now, it's interesting that the ardent atheist Richard Dawkins says that the point of evolution is to produce objects which have the appearance of being designed. He's an atheist, he doesn't believe they were designed, but he says they have the appearance of being designed. Well, I'd say they look like they've been designed because they have been designed. That's pretty logical. Now, what I said about metabolism, one thing you need for the living cell is an energy source. Now, in the body we have an energy source called ATP, and it stands for adenosine triphosphate. This is the molecule of ATP. Now what happens with ATP is you've got a very strong bond here, and what it does is it chops very high energy, so when it chops this bond, it releases lots of energy. And that's the energy currency of the body. It's so important that in fact your body would probably be making about half its own weight in ATP every day and then consuming it. And cyanide works by stopping ATP being produced, and it causes death in 30 seconds. So it gives you an idea of how vital ATP is for life, the energy currency of the body. But now we know, thanks to research done only in 1997, that the ATP is made by this tiny molecular motor. This is the world's tiniest motor, and the discovery was regarded as so important that they won the Nobel Prize. That was only about 5 years ago that they won this. And it's so complicated, I can't even draw it for you properly in this thing. This is only a schematic. See, each of these ones here has about 500 subunits and arranged in a very precise way. And it's spinning about 10,000 revs per minute. So you listen carefully, you might hear it whirring, because they're in each of your cells. But here's an example of it in very, very slow motion. This is the profile view. Of course, this is going about 10,000 revs per minute, though. And here's a top view of it. And every rotation, it produces 3 ATP molecules. But this molecule is vital for life, and yet it's an incredibly complicated motor. You couldn't have life unless you had this motor to produce the energy currency. So it looks like this motor must have been there right from the beginning. And I'd say that because this motor is so much better, so much tinier, more efficient than any motor we can design, I'd say the designer of this motor is far more intelligent than any motor designer we have today too. Some cells, this is a simple cell, has another type of motor. This is probably not essential for life, but it's still very interesting to see how complex even a so-called simple cell is. The bacterium, a germ, has a real electrical rotary motor here. This is a rotary motor. I'll actually be able to have it animated for you. And what this motor is doing is it's making a wave in this whip-like cord called a flagellum. This is a flagellum here, and by the whip-like movement that the motor generates, the germ can propel itself through the liquid it's in. So it's amazingly complex things. Even in a simple cell, you look at it in more detail, you find there's incredible layers of complexity there. So how is all this made, though? Because if God finished creating on day 6, he's no longer doing any direct creation, apart from a new believer is a new creation in Christ, but more, by and large, what God is doing is sustaining his creation. That's what, in fact, Jesus is doing. Colossians 1:15 and Hebrews 1:3, Jesus is the one who upholds the creation by the word of his power. So what God is doing now is sustaining his creation. And one way he's done that is he's programmed the instructions for all these things on an information molecule called DNA, deoxyribonucleic acid. And this is actually a real messenger molecule. It's actually storing information on the sequence of the chemical letters. Each of these rungs here is a chemical letter. And in each of our cells there's 3 billion of these chemical letters in each of our cells. The simplest living thing has almost 600,000 of them. And here's a nice colourful diagram of the famous double helix structure. It was only discovered 50 years ago. The Nobel Prize was awarded to the discoverers, Watson, Crick and Wilkins. And the other thing about DNA is it can reproduce itself, because you've got these little letters. You've got 4 types of letters in DNA. One letter is called A for adenine, and it always bonds with T for thymine. Cytosine always bonds with guanine. And what happens is that this thing will get zipped in the middle there, and see a cytosine will always bond with another guanine. This thymine will always bond with an adenine. So you've got a way of transmitting the information to the next generation. So you imagine you unzip this in the middle, and each of the chains gets a mirror image of it. It's sort of the photographic negative, as it were. There's an exact photographic negative of each of the strands, and that's how the information will be passed on from generation to generation. So not only does the DNA enable the information to be passed on, but it's information that codes for something. In fact, the information in each of our cells is the equivalent of about 100,000 books of information. These are large volumes of information. That's a lot of information. So it's very lucky that our cells aren't using paper and ink to store the information. Now, to explain a bit about information, it's nothing to do with the material it's on, because, see, I've got information in a book, and here the information is in the form of paper and ink. But the information is not the paper and ink, it's the way the paper and ink is arranged. If I read the book to you, the information would be the same, but it's in the form of patterns of sound waves. When I wrote it on my computer, the information was in a pattern of on-off pattern, magnetic patterns on a metallic disc. If it's sent by email, then the information is a form of electrical impulses. So same information, different ways of transmitting it. And in the DNA, the information is stored in the form of chemical letters. Now, it is possible to write out the information of your DNA in paper and ink form. That's what the Human Genome Project was all about. But we can do it the other way around. We can work out if we had a pinhead of DNA, in theory, we could write the information of these books on DNA. But it turns out a pinhead 2 millimeters in diameter, a spherical pinhead, would be the equivalent of a pile of paperback books reaching from here to the sun. Just about. Or 500 times from here to the moon. That's paperback books I could store on just one pinhead of DNA. Or to put it another way, see, 1,600 kilometer high pile of CDs. You know, a CD can store the entire set of the Encyclopedia Britannica, but a 1,600 kilometer high pile of CDs would be required to store what could be stored in just a single pinhead of DNA. The other way of putting it is a 40 gigabyte hard drive is not a bad hard drive, I've been told, but in fact a pinhead of DNA is 100 million times better. So you think our multi-gigabyte hard drive is something special. Well, God's information technology just leaves it in the dust. DNA by itself would just be like a blank hard drive. There's nothing there. There's no programs on it. So to program something, you need a programmer. So for DNA, you have to actually be able to write the messages on the DNA. Not just enough to have the DNA itself. You've got to write the messages on it. But you have to have a way of decoding the messages. For instance, my books are fine if you understand English. See, the English is a decoding system because it says that the sequence CAT stands for a furry animal with sharp, retractable claws. Okay? There's a code there, the letters into concepts in your mind. But the letters G-I-F-T in English, they stand for a present. Is that reasonable? But what about in German? It means a poison. And that's been a problem, I think, when the anthrax scare was on. German postal workers didn't want to handle packages marked gift. So you had the right message, but the wrong decoding system. And it turns out that the decoding system in the cell is made of lots of proteins. It's mainly the ribosome. It's a very complicated set of machinery, the ribosome. There are about 50 or so components to a ribosome. But the main amazing thing is the instructions to build the ribosome are on the DNA. But you need the ribosome to decode the DNA. So that's a real chicken and egg problem, isn't it? Because you can't have, there's no point having the DNA unless you have the ribosome to decode it, but you can't get the ribosome unless you have the instructions for it in the DNA. And one of the world's greatest philosophers of science, Sir Karl Popper, recognized the big problem. And he said that the origin of life and genetic code is a disturbing riddle. The genetic code is without any biological function unless it's translated, unless it leads to the synthesis of proteins whose structure is laid down by the code, but the machinery by which the cell translates the code consists of at least 50 macromolecular components that are themselves coded in the DNA. So the code can't be translated except by using products of its translation. And he goes on to say, this constitutes a baffling circle, a really vicious circle, it seems, when you attempt to form a model or theory of a genetic code. Thus, we may be faced with the possibility that the origin of life, like the origin of physics, becomes an impenetrable barrier to science and a residue to all attempts to reduce biology to chemistry and physics. So he thinks the origin of life is a real, is a block for the materialist. The materialists have this conundrum trying to explain the origin of life from non-living chemicals without God. To give you an idea of how the chemicals are, what the DNA is coding for is all sorts of different types of proteins. Here's one type of protein, the fibrous protein. It makes your hair, and you see how it's at base it's curled up. You see it's got the alpha helix, it's a coil, and you've got coils of coils bundled together, and then you've got bundles there into a hair cell. So you see how complicated. You've got the protein, you've got bundles of the protein, and then you've got further fine structure. And that's in your hair. You didn't think hair was that complicated, did you? The other type of protein is a globular protein. You see, these are very important and very highly designed for certain functions. Now, one of the most important functions of a protein is the enzyme. And they speed up reactions by many orders of magnitude. Order of magnitude is a power of 10. One order of magnitude is 10 times. 2 orders is about 100 times. 3 orders is about 1,000 times. And it turns out there's a vital reaction to make the building blocks of DNA, and it needs an enzyme to speed it up by 18 orders of magnitude. That's 1 followed by 18 zeros. That's how much the reaction is speeded up. And in fact, without the enzyme, it takes 78 million years to work instead of being a few thousandths of a second. Now, the cell just couldn't survive if it took 78 million years to make this vital reaction. The cell would have long since broken down by then. And even more recently, and this was only discovered last year, 2003, it is last year, isn't it? Yeah. And this one speeds it up by 21 orders of magnitude. So without this enzyme, a reaction would take 1 trillion years. Now, even the Big Bangers think the universe is only about 15 billion years. And so this is about 100 times even the evolutionary age of the universe that this reaction would occur if it didn't have this enzyme. And here's one of the researchers involved in this discovery of the way enzymes work, how much they increase the reaction rate by. So without catalysts, there'll be no life at all, from microbes or to humans. It makes you wonder how natural selection operated in such a way as to produce a protein that got off the ground as a primitive catalyst for such an extraordinarily slow reaction. Now, this is quite a statement of faith there. Well, because natural selection couldn't have done it, because you haven't got a living cell without this enzyme to work. And if you haven't got a living cell to reproduce and pass the information on, natural selection can't work. But it just shows you that he's got this preconceived idea, this bias, that somehow natural processes must have made the first living cell. I also want to now give you an example, a very important distinction to make, and this is the distinction between order and complexity. So you can have randomness. See, this is a random sequence of letter. I just typed it without even looking at the keyboard. I don't usually look at the keyboard anyway because it's not supposed to, but this is even more random than normal. And this is totally randomness. You see, a jumble, a junk pile. Another concept is order. Now, the point about order is a repetitive, low information sequence, because what I've got here is I can have write a program to make this, and it says A, B, C, D, then repeat. So there's only really 4 letters of information there, and then I've just got repetition. You see, that's not complexity, that's order. And the parallel to that is the crystals. See, crystals are very highly ordered solids, and they're usually very low energy solids. And this is one of the crystals I worked on for my doctoral thesis and got a paper published. So don't let anyone tell you that creationists don't publish real scientific papers, because I've certainly published in the scientific literature. Don't bother taking notes about this, okay? And I'm saying, well, here's an example of some crystal I worked on, and it's a very highly ordered system. And all this does is you have this unit here. Once you've got that unit there, you can just repeat it over and over again. So crystals are very highly ordered, but don't really have that much information in them, because just repeating the same amount of information. Now, the other thing we have is specified complexity. In the beginning, God created. You see, that's not ordered. There's no repetition there, but it's definitely not random either. In fact, for a program to work this out, you'd have to say you've got a program which says I, then N, then space, then T. So you've got to specify the letters there. And living chemicals, the DNA and the protein, are like the specified complexity. They're not regular and repeating, but they're also clearly not random. Like you've got this is a protein called myoglobin. It stores oxygen in the muscles. And therefore it has to be very highly organized to store an oxygen in the right place, but also releases it at the right time as well. No point storing it if it won't give it back again. So it has to store it and then give it back at the right time. And that requires a lot of organization. It's not just random, it's not just like a crystal with the same pattern repeated over and over. And in fact, John Kendrew was the one who first discovered the structure of myoglobin. He used X-ray diffraction. That's how you normally work out the structures of molecules. And he said, you'll be amazed, just like the world was in 1960, at the beautiful intricacy of this protein. As indeed we should be. What's sad, though, is that a lot of people believe that this intricacy came about by time and chance and natural selection. And to get back to the DNA code, see, even a DNA code, which is to translate from a DNA information into the proteins it's coding for, has amazing amounts of information in it. Like, for instance, a certain sequence of 3 letters of DNA code for one protein letter. See, 3 base pairs of DNA code for one amino acid in a protein. But from a chemical point of view, some of these amino acids are very similar, very hard to separate from a chemical point of view, but in the human body it makes an enormous difference to get one out of place. Because the enzyme systems in living things are far more sensitive. You need to have things in the right sequence for it to work. And therefore, for one thing, what this is, the molecule is to link the 3 bases which code for isoleucine. So it's linking the bases of isoleucine to the actual amino acid isoleucine. And it's an amazing system here, because what it does is, first of all, you've got lots of different amino acids linked to different bases here. But what this enzyme is doing, it screens out the ones which are too large, first of all. And then it actually has another sieve which screens out the ones which are too small. And it's just the right size that the isoleucine one comes out. Anything bigger is blocked off at one end, and anything smaller is let out the other end. And this is an amazing amount of control. And yet you need this protein for the DNA code to work. If you haven't got this protein, you cannot get the DNA code coding for isoleucine. Because you might find the 3 letters might produce any of these other amino acids instead of just the isoleucine which is required in the protein in this particular place. In fact, there's always another thing to talk about to show you how chance is not enough to produce things, but because I said natural selection won't work, so you have only got chance. And let's see what sort of chance we have. And let's make it as generous as possible for the evolutionists here. If they estimate 10 to the power of 80 atoms in the universe, that's 1 followed by 80 zeros. That's the number of atoms in the entire universe. And if you say 1 trillion atomic interactions per second, 10 to the power 12, and 10 to the power 18 seconds in the universe, if you believe the Big Bang is true, which I don't, of course, that's the 15 billion years. Now, that means that there are 10 to the power of 110 interactions possible. That's 1 followed by 110 zeros. That's the total, the maximum number of interaction between atoms that are possible, even if you grant the entire universe was participating, even if you grant that it's as old as the Big Bang as say it is. There are 20 amino acid letters, and if I'm saying there are 256 enzymes for the simplest life, and that's, I think, very doubtful. I think it's going to be far more complicated. I think this is far too simple, as I mentioned before. Now, each of these enzymes is composed of lots of amino acids. Now, there might be some leeway in some of the amino acids, but I say there are certain ones which can't be chained because they have to be in that right shape for the reaction to occur. So I'm just being generous to say that only 10 of them have to be exactly right. But when you work it out, you find that there is one chance in 10 to the power of about 3,000 to get the right sequence for life. Now, when you think of you've got a bank card, you've got a PIN, you know, I hate the term PIN number. I mean, it's PIN, isn't it, right? Personal identification number is ridiculous. Okay, so you've got a 4-digit PIN, and you're not supposed to leave it lying around there. You're not supposed to have it written down. And the point is, if someone else steals your card and guesses the right PIN, the bank's going to say that you left it lying around somewhere. Because it's 1 in 10,000 chance, or 3 in 10,000, you've got 3 goes of getting it right. 3 in 10,000 chance of getting it right, and the bank thinks that's enough protection for you. But here, it's like getting a 3,000-digit PIN number. See, if a 4-digit PIN number is pretty good protection for the ordinary person using a credit card, well, what's a 3,000-digit PIN number like? It's totally impossible. And when I say 10 amino acids must be the same, well, that's incredibly generous because you've got plenty of proteins like calmodulin where 142 out of the 143 amino acids must be exactly right. And to try and get that by time and chance is just amazing. Just that one protein alone, the chance of getting that is about 1 followed by 185 zeros, just for that one protein, which is essential for metabolizing calcium. Now, to get back to the DNA base pairing, I think it's important just to cover what's going on there, why the DNA base pairing is so important. It's important for the decoding and also important for transmitting the information on. So you see how these DNA bases are exactly coded so they match up there. It's amazing how the way God programmed the constants of nature so that these molecules would turn out to have exactly these matching hydrogen bonds, which are so important for living things. Now, I want to just change tack a bit and just go right back to the level of ordinary chemicals. So I've shown you, I think, how complex a living cell is. Now I want to just show you what you have to get started from scratch to get to a living cell. Now, one of the most famous things is the Miller-Urey experiments, which are just over 50 years old now. So Urey was already a Nobel Prize winner, and Stanley Miller was his graduate student, and Stanley Miller designed this apparatus which really turned the chemical evolution world, really gave an emphasis to the chemical evolution theories. Because what he did with this apparatus, you see, he boiled water, the water circulated around, and we got this atmosphere of methane and ammonia and hydrogen, and you find it sparked in this reaction chamber, and then the circulating water pulled any products back, and they were trapped down the bottom there. And amazingly enough, he found a few traces of amino acids where he had none before. And therefore, this was touted all around the world. You find it in all the textbooks of how Stanley Miller, this graduate student, had shown that amino acids, the building blocks of life, could have come about from simple chemicals. However, there are a number of things drastically wrong with this experiment. Now, one thing is, oxygen must be excluded from this, because oxygen would not allow any amino acids to form. Oxygen is actually a very reactive chemical. And we think of it as being essential for life as it is, but really it could be quite poisonous because it reacts with so many different things. In fact, even today, oxygen can be a poison. Like premature babies often went blind because at birth they were pumped with far too much oxygen and they made their eyesight, it stuffed up their eyesight. So here's a case oxygen can be a poison. See, oxygen would not allow any amino acids to form any amino acids in any primordial soup. If there's oxygen around, the oxygen will eventually destroy them. So they're assuming there's no oxygen present. Now, once again, you have some bias there because people say, well, what's the evidence there was no oxygen in the past? Well, we're here, aren't we? And we couldn't have got here if there was oxygen in the past. You see, that's again the circular reasoning going on. And nowadays, people don't even believe there was ammonia, carbon, methane, and hydrogen in the atmosphere. Even that's been gone for some time. And now they try and do experiments with carbon dioxide and nitrogen, but then there's a far lower amount produced and a far lower variety produced of amino acids. And if you have carbon dioxide and nitrogen alone, nothing happens. But only in last month, they found evidence in some of what they call the world's oldest rocks. I don't believe their dating system, but according to their dating system, these are rocks 3.8 billion years old. And they found, because they looked at the uranium and thorium, and they said there must have been lots of oxygen around. And that was about as old as the oldest rocks, they say, too. And what they said is evidence of photosynthesis happening, but all they really found was evidence of oxygen. They're assuming it must have been produced by photosynthesis. The green plants produce oxygen for us. So they're assuming that this amazingly complicated process called photosynthesis was already around as old as the earliest rocks. And that's a problem. How do you get such a complex process like photosynthesis happening so early? You haven't got so much time as people think. You haven't got the billions and billions of years if photosynthesis was around that early. But if the oxygen wasn't produced by photosynthesis, you've got another problem, because if there was oxygen already in the atmosphere, then this chemical evolution could not have happened. And that's what Miller's experiment shows, that chemical evolution of amino acids can't happen if there's oxygen around. And yet now it's almost certain there was oxygen even in the oldest rocks. Another thing about the Miller experiment is that it had a trap which isolated the products from the destructive energy source. It's very convenient that you have this product circulating, and then any products are protected from the destructive energy, which would just destroy them really quickly. And this is not realistic, because in the real primordial Earth, if there's no oxygen, there can't be any ozone to protect you, because ozone is just an oxygen molecule with 3 oxygen atoms instead of 2. So if there's no oxygen, there's no ozone, so you've got enormous amounts of ultraviolet. And there's far more ultraviolet that will destroy amino acids than produce it. And also, the destruction is far more efficient than construction. So you've got 2 strikes against it. One is you've got far more of the destructive stuff, and the destructive stuff is far more efficient. So overall, you've got about 100,000 times more effective at destroying than producing. So you've got this, the amino acids produced in the supposed primordial atmosphere, but all that time it's being exposed to this devastating flux of ultraviolet light, destroying it. And even if it gets into the ocean somehow, from miles up in the atmosphere into the ocean, it's not safe there, because ultraviolet can penetrate to tens of meters into the ocean. And don't forget, you can get sunburnt while swimming. The water won't protect you. So I'd say the trap is what I call unacceptable level of investigator interference. You see, to say this is a simulation of the primordial Earth is just not true, because you've got this example of intelligent design there, the trap, to protect the molecules as soon as they've been formed. There's no acceptable trap in the primordial Earth. So let's look at some of the philosophy behind this. Is this evidence, is the Miller experiment producing amino acids evidence for chemical evolution? Well, you could say so. Yeah, it's evidence that amino acids can be produced. So yeah, in one sense it's evidence for evolution, but I'd say it's also evidence against it, because the amino acids are produced, even if you grant the impossible conditions, they're produced in very tiny traces. They are grossly contaminated, and they're racemic, which is an equal mixture of left and right-handed molecule of amino acids, which are all unsuitable for life. So in one sense, it's against it, because even given the impossible conditions, you get amino acids which are just not suitable to produce living things. And here I'm just distinguishing between the data and the interpretation, because I don't dispute the Miller experiment data. I dispute the interpretation that it shows that life can come from non-living chemicals. And as I say, depending on your worldview, your belief system, you can interpret the Miller experiment either for or against it. I think it makes far more sense to interpret it as evidence against the chemical evolution ideas. Now, to go from amino acids to proteins, see what we've got here, you've got two amino acids, they have to link up to form proteins, hundreds of amino acids to form a protein. And what actually happens, so they come together, and what happens, these hydrogen and the oxygen react to form water, and they join the protein together. See, here's the protein, the peptide bond. See, once these were separate, now they're joined together, the peptide bond, and it releases the water. It's called a condensation polymer. Now you can continue this again. You see, you've got another amino acid coming along, and again you've got the link up here, and you get yet another peptide bond. You see, you can go the other side too. And you get yet another peptide bond. See how this can keep on growing? However, there's a big problem though. For one thing, is sometimes you get other reactions that can occur. You see, a real chemist does not do this. In fact, a real chemist would make sure that any of these groups here don't, well, this one won't, but there are some proteins which have quite reactive side groups on the end, and you have to protect it. You actually react it to something which will protect that, and then after it's joined to form a protein, you remove that protecting group. So it's quite a complicated process to add the protecting group, then to remove it. But of course, the primordial Earth did not have these organic chemists doing that for you. Now, there's another problem here. Let's look at this again. Don't forget the water molecule, because if you want to make the reaction go this way, downwards, you have to try and remove the water. And in fact, a chemist will have chemicals around to remove the water that's produced there. And he certainly wouldn't have water in the reaction vessel. It would be the height of absurdity for a chemist who wants to make a protein to have water around. But do you think the ocean has any water around? If the ocean was a primordial soup, I'd say there's plenty of water around, which means the reaction's going to go this way. In fact, proteins and all the other things, they tend to break down in water. They don't form in water. The primordial soup, the primordial ocean, is the last place you expect to find this thing happening. It's just against basic chemical laws. Another thing we find here, supposing we have other chemicals reacting, instead of amino acid, you have something like this is ethylamine, and this reacts the same way, same thing happens, but you notice one thing about it, the chain is terminated there. And here's another example of that, acetic acid or vinegar. And once again, you've got a chain terminating there. And the point about, see, the Miller experiment produced about 5 times as many of these chain terminators as amino acids. So once again, you could never manage to extract the Miller experiment gunk and try to produce the proteins from it, because you've got all these other chemicals there which would just block the chain off. You could never get a protein chain growing in the stuff produced in the Miller experiment. So this, again, alone is enough to totally blow away the chemical evolution ideas. The other thing is, the fact is, the molecules of life, the sugars of the DNA and RNA, the proteins, they are all of one-handedness. You see, my left hand and right hand are mirror images of each other. And so are the different proteins. They are mirror images of each other. And the thing is, in living things, all the proteins are have amino acids which are left-handed. But the primordial soup could only produce an equal mixture of right and left. And to try and separate these things, you need to have something which is already handed. Organic chemists can do it because they've got plenty of things from nature which have one-handedness or the other to separate them. But in the primordial soup, you haven't got organic chemists around to do it. So once again, the primordial soup produces amino acids which are totally unsuitable. And here's the problem. You need to have all one-handedness to produce the proteins of life, and also all one-handedness of sugars to produce the DNA helix structure. And without the helix structure, it could not code for information or reproduce itself. And in fact, if you tried to have the wrong-handed form of the DNA building blocks, it actually blocks the chain off. A chain won't grow if you get the wrong-handed molecule there. Even a single impurity will actually block the chain from growing. Now, one thing we've got here is called the RNA world, and that's one of the ideas of modern origin of life chemistry, is that life began with RNA, which is a bit like DNA, but it's got a couple of differences, like the sugar's a bit different. The point is, how do you get the building blocks of RNA? You see, the sugars are very reactive. They need reactive formaldehyde to form. See, formaldehyde is used for preserving corpses because it reacts with proteins and cross-links them and makes them hard. It's a highly reactive chemical. You're not going to get formaldehyde accumulating on a primordial earth because it reacts with everything in sight. And the sugars themselves break down very quickly, and especially at high temperatures, because one idea is that life formed at these hydrothermal ocean vents. But the problem is, sugars break down at high temperatures really quickly. We have organisms, these extremophiles, thermophiles, they live in these extreme conditions. They have very efficient error-correcting machinery because the heat is breaking down a lot of their vital molecules, but they're repairing them as fast as they're being broken down. So you need these advanced repairing mechanisms before these high-temperature organisms can even live. And you need to have the sugars all right-handed, and sugars even react with amino acids, which is a bit of a problem. They're not supposed to do that, but in fact this is what the problem is, because that's how foods will often go brown. If you break the cells and you allow the sugars and the amino acids to react with each other, you are going to form browning reactions and not the right reactions you need for living things to form. You've got the bases here. So you've got two types of bases. Here's the pyrimides have one ring, purines have two rings. And the point is, one of these bases, cytosine, is incredibly unstable. There's no decent way of producing cytosine. And again, it's unstable at high temperatures. And look at the common reasoning we have here. And you find this in heaps of the evolutionary propaganda. You find traces of chemical A and B in the prebiotic simulations, and they're usually mutually incompatible. You can't have sugars produced in the same reaction that produces the DNA bases or which produces the amino acids. They are totally incompatible. But you find one experiment produces a trace of A, one has a trace of B. The next step is you get from a maxi-pure chemical company pure concentrated homochiral A and B from a chemical company, which has already done the purification for you, and then you're reacting to produce traces of C, and then you proclaim, well, there you go, we've produced C from primordial earth conditions. Well, in fact, there's been an enormous amount of intelligent design there to get the pure and concentrated forms of the chemicals to react them together. So it was never produced in these Miller experiments, and it never could be produced. And another big problem is, if you are trying to get the building blocks of DNA, you have to link the base of adenine here with the sugar, and it's very hard to do. But even when you have pure adenine and pure ribose and remove the water, because again, to link them together, they release water, so you've got to try and exclude water. Even under these favorable conditions, you can't get the sugar bonding with the one ringed amino acid. Okay, so even that's not possible. And you need phosphate to produce the backbone of DNA, and phosphate gets precipitated by things. Calcium would immediately react with phosphate and precipitate it out. And just to conclude here, to show you that these are only scratching the surface of the many reasons why life couldn't evolve from non-living chemicals. See, Yockey again, he said the paradigm of the primordial soup was worth consideration. Now the entire effort in the primeval soup paradigm is self-deception on the ideology of its champions. Then he says, in order to make progress in science, it's necessary to declare the decks to speak of failed paradigms. This must be done even if it leaves the decks entirely clear and no paradigms survive. And what he means is that no naturalistic paradigms. But his belief in a primordial soup on the grounds that no other paradigm is acceptable is a fallacy of the false alternative. In science, it's a virtue to acknowledge ignorance. There's no reason that this should be different in the research of the origin of life. But the reason they don't want to get rid of primordial soup is because the only alternative is special creation. And that would mean we're accountable to our Creator. We can't have that, can we? And here's the thing which really sums up a lot of the best, is that even if I can synthesize life here, then I've proven that no intelligence was necessary to form life in the beginning. So thanks for listening to me on this fairly complicated topic, and all the best for the rest of the camp.